All right, so here we go, trig lesson 2. Today's lesson is going to be on the sine law. So the sine law is going to be used for triangles that are not right angled. Okay? So non-right angled. So if you see on an exam or anything like this a right-angled triangle, go ahead and do SOHCAHTOA or Pythagorean theorem like you remembered on today's quiz. If it's non-right angled, your options are sine law or the cosine law. Today we will just cover the sine law. So the first class example is a review of SOHCAHTOA. So what they're going to show here is that if you look at this triangle, triangle ABC is not right angled. Do you agree? So what they're saying is you could problem solve your way out of it by dropping this perpendicular, drop a 90 degree, and then you could do two triangles separately. You don't have to do that. We're going to use the sine law. Okay? All right. So we're not going to do the proof of the sine law. We're just going to use it. So this notation, you are comfortable with it. You've seen it before. So this is lowercase a over here. This is lowercase b here, and this is lowercase c there. Because the vertex will be on the opposite side. It's just a convention. That way, when you go to use this formula, everybody's on the same page. If everything's labeled properly, then I'm not going to make a mistake with using the formula. Now for this formula, there's three terms. Like, that's ridiculous. Why is there three? It doesn't matter. Just do two at a time. Just use two at a time here. All that formula is saying, and the proof that follows it demonstrates it mathematically why it's true, is that if you take a ratio of the side length and divide it by the sine of the angle opposite, all those ratios are the same. So we can just use this fact to solve non-right angled triangles quite easily. Okay? So we're not going to worry about this proof. I'm just going to show you how to use it. And they want me to use SOHCAHTOA again. I'm not going to do that. So let me undo that. Let's solve this using the sine law, not SOHCAHTOA. Oh, the SOHCAHTOA was class example 1. Now we're going to use the sine law. So pardon me. So here we go. So mark off 75. And just draw an opposite arm like that. And then you call this guy little a. Okay. So little a goes with sine 75. It's always just a ratio with the angle and the side across from it. Okay. And which angle are we allowed to work with? Well, we're allowed to work with 35 because they gave that to us. So 35 goes with this guy. It's always the angle on the side across from it. So the way that I've written my formula, it's the side on top and then the sine of the angle underneath. So then 12.5 goes up top, and sine 35 goes on the bottom. And now you cross multiply. And that's sine law. Easier actually than SOHCAHTOA. So we could have did the proof, and in fact we might do the proof later in the course, but for right now I just want you guys to memorize procedure. Okay. Now in terms of the cross multiplication, which two things do I times? So those two times, and then which one would I divide? The sine 35. So a lot of you might be drawing it like this. Yeah, the fish. How many are in Chem 20 or taking Chem 20? Chem 20. Do you guys know those equations, like those pressure volume equations? It's like P1 over P2 equals V1 over V2. You got to cross multiply through those. This is very similar in the terms of the math necessary. So let me just show you the math here before we move on to the next question. So, one sec. Abel, put that down, man, and take your headphones up. We want to isolate for A, and right now A is top left, right, Norvisi? A is top left. So to isolate A, what do I got to get rid of? The sine 75. So where's that sine 75 going to go? It can only go right there. So to properly write this out, you would have 12.5 multiplied by sine 75 over sine 35. Okay? Which is the exact same thing as that blue cross multiply would have been. Okay, so that's the proper way to write it out. And I know some people want the proper way and some people want to do the shortcut, so I offer both. Make sure you're in which mode? Degree mode. Mode, make sure it says degree. 12.5 times the sine of 75 divided by the sine of 35. I got 21. All right, it looks like centimeters, so 21 centimeter. All right. Next one. Use the sine law to determine the measure of angle ACB. This guy right here. Look for the middle. You look for angle C. Because the way you would read that, A, C, B, we're looking for this guy. So that's the one we want. All right, so let's set up our sine law. Which two go together of the information given? Those two. So this is the, I would call this like the guide, or in this case, the guiding ratio, because the sine law is just a ratio. So of the information given, that's the guiding ratio. If you look above, what was my guiding ratio above? The 12.5 with the sine 35, right? Those two go together. So that's the piece of information you know. And if you look at what I did there, I put the side on top and the sine on the bottom. That doesn't matter. You could put the sine on top and the side on the bottom. As long as you're consistent with that, it's okay. So I'll do that here. Sine 110 goes with 9.4. Okay, so as long as I'm consistent with that, I'll be okay. So I'm trying to find like, all I'm saying is it doesn't matter if the sine is on the bottom or the top. It doesn't matter. As long as the other equation follows the same structure. Yeah. So then over for this one, it would be sine C. What does sine C go with? Nope. You'd have to go straight across, right? But it's not there. See the problem? I can't do it yet. So what I could do is use the 6. How could I use the 6? Yeah, the sine 110 goes with 9.4. That's for sure. But how could I use the 6? 6 goes with B. So I can first find the angle at B. Okay, so it's always the side opposite the angle given. So 6 goes with B, 9.4 goes with A, and question mark goes with C. Is everybody on the same page with me? Vertex with opposite side in a ratio. Now I want to solve for B. I can't just cross multiply the shortcut. Okay? I mean, you could, but this is a problem. Where does that 6 need to go if I'm trying to isolate for sine B? On the top. So then I would have 6 multiplied by sine 110 over 9.4 equals sine B. Are you guys okay with that so far? So 6 times sine 110 divided by 9.4. I get 0.5998. If you did the shortcut, you should have got that as well. How do I get B though? Not sine B. What's the opposite of the sine thing? Good. Sine minus 1 thing. Inverse sine. Inverse sine of that answer, and I get, yeah, 36.9 degrees. You guys okay with that? Now let me erase all this crap. So I know up here is 36.9 degrees, and this is 110, so how could I get this missing angle C? All the angles in a triangle add up to 180, so if you know 2 of them, you just have to subtract from 180. People might forget that fact. For 20-1, you can't forget, or 20-2, you can't forget this fact that all the angles in a triangle add up to 180. Okay, so they wanted us to solve for C. They purposefully gave us the information for B, and then you have to do the 180 argument to get C. Okay? So hopefully you also wrote this one down, because there's just not enough info to do that one. Not enough info. Okay, so I'll just let that sit for a minute. And once I'm done talking, I'll give you guys a summary for this. Okay? Class example 4, folks. For this question, What's hard about this question is you have to take the question, Ozzy, and you have to put the values into the right spot. Okay? So let's do that. The first one says PQ, Kalela, is 440. That one's an easy one, right? So put 440 in the right spot. Done, right? Easy, right? So here's 440. Good. You guys are alive. Perfect. So PQ, right here. That's an easy one. Then he takes these measurements and finds that, okay, now this is the tough one. Some people will forget this. QPR is 46. Okay, good. You're listening. P is 46. And then the next one, Q is 75. And then it wants us to calculate the perimeter. Oh my gosh. So you have to have every side, yeah? Okay. Who said that? Parker? You have to, he said it, you have to find this. Why? Because what is the 440 connected to Trinity? R. Yeah, if you're going to be using that sine law ratio, you have to have this. You have to have one side and one angle together in a ratio. You have to have that. Okay? So how could I find question mark? It's 59? Thank you. That's the guide. That's the guide. That's the easy part. But if you don't do that, you can't solve this problem. Sorry, they updated this system and I'm like learning all the new buttons. All right. So sine of 59 goes with 440. And again, it doesn't matter if I put sine on the top or the bottom as long as you're consistent. Okay, so that's our guide. That's our guiding ratio. Can I have another ratio? So she said sine 75. So which one does 75 go with? Good, Parker. No wonder they put you quarterback. You're a thinker. Small q, he said. Now to solve this, cross multiply, what would you do? Times those two, and then divide this one, right? All right. That's a q. That's my lowercase q. Okay, I'll put it like that, if that helps. So okay, so that's the cross multiply. Okay, so I got 495.8277. Okay. So, ladies and gents, guys, if that's my guiding ratio, I can just do that one more time. Just copy that down. Do it one more time. This is my guide. Good. Just use the 46 instead. And then you would find little little p. Okay? Because 46 is at the vertex labeled p, going across from that would be little p. So again, this is little q, this is little r, this is little p. So again, if you notice, just as you quickly are getting better at cross multiplying, where is the letter p? Down on the right? So it needs to go up on the left. So then the sine 59 needs to get out of there, so he'll go down and 440 will go up. Okay? So just as you're getting better at cross multiplying, bottom right goes top left. I could put a little 1 there underneath if it helps. Then sine 59 is in the way, so he goes down, and 440 is in the way, so he goes up. So thank you for being patient. I know some of you already have this. So I got the 369.2505 roughly. Oh my gosh. Yeah, so what I do is I never round intermediate values. I only round at the end. And adding up all the sides, that's what you have to do. Add up all the sides, including the 440 and the total perimeter. I'm getting like 1305. And it says nearest meter, so now I'll do what you're saying. Just no decimals. Nearest meter, 1305. I'm so proud of you. Okay, so you have the assignment that follows, and we're back on schedule with quiz at the end. Well, one quiz for sine law, right?